All right, well, here we go with lesson 9.5. You guys are going to be able to solve quadratic equations by graphing in this lesson. So let's get a little bit of vocab in there. Our first blank, a quadratic equation. Whoa, what is that letter? There we go. Quadratic, and then equation. Is an equation that can be written in the standard form, ax squared. This will be familiar. You guys have seen the standard form before. So ax squared plus bx plus c equals 0. It is an equation, so we're going to have that equals 0 as part of these equations now, where a, b, and c are real numbers, and our a value will never equal a 0. So you'll always have some number with your x squared. If it could be a 1, so 1x squared is just x squared, or 2x squared, 3x squared, something like that. So we're going to graph our quadratic equations, look at the graph, and get our solution. This entire second half of our chapter is solving quadratic equations, and we're going to have several methods to do that. So, the first method we're learning about, solving quadratic equations by graphing. First thing you're going to do is write the related function. So what that means is you are going to be given an equation. So it'll have an equal sign. You may have to get it so that it's in standard form. So let me just, here's our here's our ax squared plus bx plus c equals 0. When it says write the related function, what that means is you're going to take the equals 0 and replace it with a y equals. So when we write the related function, it's going to end up as y equals ax squared plus bx plus c. So that just puts it into something that we can graph. A related function is with a y equals instead of an equals 0. Step 2, we will go ahead and graph the related function. Once it's graphed, we just look at the graph to get our solutions. Step 3, you will find the zeros of the related function. Remember, related function is just when we put it into graphing form, basically. As a reminder, the zeros of a graph are your x-intercepts. So your parabola may cross the x-axis twice, and you would say, oh, here's a solution and here's a solution. Those zeros of the graph that we worked on before are your solutions. Maybe this is at a -1 and a +3. I'm just kind of guessing on what those values might be right there. You know, 1, 1, 2, 3. This one right here just has one x-intercept or one solution. I'm going to say maybe that's at a -1. I'm just taking guesses right here. But you would be able to look at a graph and say, oh, where does my parabola hit the x-axis? Those are my solutions to the equation. Remember, you will have some parabolas that never cross the x-axis, which means there's no x-intercept, which means there are no solutions. And we would put no solution for our answer. Okay, so let's just try a couple of these so we can see what we're doing. Solve by graphing 2x squared minus 2, equals 0. So write the related function. Remember, we're going to take the equals 0 part, replace it with y equals 2x squared minus 2. And then we're just going to graph that. We've done this graphing before. Not a ton of space here, but remember the first thing you're going to find is your axis of symmetry. That's your x equals -b over 2a. You notice here's your ax squared and there's your c value, so our b does equal 0. So you're going to have a -0 over 2 times a. 0 divided by 4 is 0. So our axis of symmetry is x equals 0. So we will, gotta move this down, there we go. We can go ahead and put that on our graph. Okay. We also need the vertex, so we're gonna kind of scrunch our work in, or maybe write it, I don't know, maybe I'll write it over here. our vertex is 0 for the x because we know that the axis of symmetry and the vertex have the same value. And then we're going to plug in a 0 for the x into our equation. Y equals 2 times 0 squared minus 2. This all 0 squared is 0, 0 times 2 is 0, minus 2, and we get a negative 2. So our vertex is at negative 2. So 0, negative 2 right there. Maybe I will put a little V right there so I know that that's the vertex. Now, normally we would, well, we will do it actually, not normally. The third thing we find is our Y-intercept. So Y-intercept is where you plug in a 0 for the x, plug it in to get the y. It's also going to be your c value, which we can see as a negative 2. So if you remember, we have some graphs where your vertex and your y-intercept are the same point. That happens when b equals 0. So we could have predicted that this would happen. So we've got our y-intercept that's already plotted. We can't get any reflection points. You know what? I'm going to add in a step 4 right here, just to help us be a little bit more accurate. If you get this situation where your vertex is on the y-axis, I'm going to put it in step 4, we are going to create a reflection point. So what we might do is let's pick another value for x. Let's plug in when x equals 1 so we can get another point. So we're going to plug in a 1 for the x, y equals, and I just went to a point, you know, on the right side of the axis of symmetry, somewhere over here. Y equals 2 times, we're going to plug in a 1 for the x, and we'll do this math. So 1 squared is 1, so 2 times 1, oops, minus 2. 2 times 1 is 2, minus 2, and we get 0. So what we just found was a point on our parabola. We plugged in a 1 for the x, we did the math, and we got back a 0 for the y. So that's a point that we can plot on our graph. So 1, 0 is right here, and then that gives us a reflection point. So I can reflect it over to the other side in its same spot, and now we're going to have a better looking parabola right here. Okay, so we graph the function. Now to find the zeros, remember zeros are where your parabola crosses the x-axis. So here's our x-axis. Here's our x-axis right here. We're crossing it right here and right here. So our zeros of the graph are x equals a negative 1 and a positive 1. That's what our solution is based off of the graph. Now the check is if those are correct, it should work when we plug it into the original equation. So let's look at the original equation. 2x squared minus 2 equals 0. Let's plug in a negative 1 first. So 2 times negative 1 squared minus 2. You'll do the exponent first. Negative 1 squared is a positive 1. So 2 times 1 minus 2. We want to know, does it equal 0? Does it equal 0? The right side of the equation. Basically, does it work when you plug it in? 2 times 1 is 2, minus 2. 2 minus 2 is 0, equals 0. It worked out. Check. Nice job. Now let's plug in the positive 1 for that check. We'll do 2 times positive 1 squared minus 2. Does it equal 0? All we're doing is we're saying, hey, our answers for x are negative 1 and 1. Let's plug it in and make sure it works out. So you would do your exponent first. 1 squared is 1. So 2 times 1 minus 2. I'm just copying down the rest of the equation. 2 times 1 is 2 minus 2. 2 minus 2 is 0. And I just kept carrying down that equals 0 over here from the right side of the equation, and then we ended up with a true statement. 0 does equal 0, so that worked out. We found the solutions. So solve by graphing, we solved it, and we got x equals negative 1 and positive 1. All right, let's try another one. So I'm going to scroll up. We'll ignore all that other writing we see. Solve by graphing. x squared plus 5 equals 4x. So write the related function. We do want to start by putting everything on the same side and 0 on the other side. So I'm just going to subtract 4x from both sides. So I get x squared minus 4x. I'm going to put it in standard form, plus 5 equals 0. All right, so the related function, we take the equals 0 and replace it with a y equals x squared minus 4x plus 5, and we're going to graph this function. So first thing we're going to find is the axis of symmetry. So our axis of symmetry is x equals negative b over 2a. So negative, our b value is negative 4 over 2 times our a value is 1. So a negative 4 goes positive. 4 over 2 equals 2. So we've got x equals 2 for our axis of symmetry. So we come over to our graph. We're going to draw on that vertical line at 2. All right. And again, I definitely should have more room for these, but we'll make it work. The second thing we find is the vertex. Well, we know that the x value will be a 2, so we just have to plug that in and see what we get for the y value. Y equals 2 squared minus 4 times 2 plus 5. 2 squared is 4 minus 8 plus 5. I'm just kind of simplifying. I did the 4 times 2 to get that 8. And then left to right, 4 minus 8 is negative 4. Plus 5 is a positive 1. So 2, 1 over 2 up 1 is our vertex. Okay, so right now I'm making a prediction. I can see that that vertex is above the x-axis, and I can see that this is going to be a parabola that opens up because my a value is positive. So I don't think this is going to have any solutions. I don't think it's crossing that x-axis at all. Of course, we will follow through with the work to prove that one way or the other. You know, maybe we're right, maybe we're wrong, but that's what I think is going to happen here. And I can make that prediction because, you know, we talked about what these graphs should look like based on some characteristics. All right, but we're going to keep graphing. The next thing we need is our y-intercept. So the y-intercept is a 0 for the x, plug in a 0 for all the x's. It's also the c value, which is a 5. So I'm just going to take that shortcut. Plot 0, 5 right here. That is our reflection point on the other side. And we can draw in our parabola. Find the zeros. There are none. This parabola did not cross the x-axis. When you're asked to check, there's nothing for you to check. You don't have a value to plug in for x, so this is done. What is your solution? There is no solution. Our parabola did not cross the x-axis. So there's an example of what it looks like when you get a no solution for your answer.